So our next lesson is higher order homogeneous linear differential equation with constant coefficients. So of course, ang objective is after this session, the students should be able to reduce or use reduction of order to solve higher order homogeneous LDEs. So ano ba yung general form ng ating homogeneous LDE? So it's in the form of a to the n. So derivative or nth derivative of y with respect to x, then n minus 1 derivative of y with respect to x minus 2, so on and so forth, and then until you have reached derivative of y with respect to x plus a sub oy is equal to 0. So the linear differential equation is said to be homogeneous if the right side must be equal to 0. So since ang ating LDE ay with constant coefficient, so therefore an minus 1, minus 2, a1, and a0 are all constants. So this can be written as differential operator. So using a differential operator, d to the n plus d to the n minus 1, n minus 2, d, and then wala na. So d to the 0 ito, so constant na siya. So again, a1, an minus 1, minus 2, a1, and a0 are all constants. So this exponent represents the order of the differential equation. So d to the n. So it means that it is nth derivative with respect to a certain independent variable. So the used to independent variable that we are using ay x or p. So it depends kung ano yung ginamit natin. So method 1, so there are two methods, reduction of order and then using characteristic roots. So ang objective natin dito sa reduction of order is from the word itself, reduce higher order to first order. So if it's fourth order, gagawin natin siyang first order. So yung third, gagawin first order, so on and so forth. So let us try to illustrate the principle. So this is expressed in terms of the operator na. So again, this can be written as second derivative of y with respect to. So I will be using x here. So by the way, what are choices? Okay, so since x yung ating independent variable, so I use x here. So plus 5 derivative of y with respect to x plus 6y is equal to 0. So yun ang ibig sabihin nitong d operator na to. So again, the exponent of d represents the order of the differential equation. So again, from our first discussion, so the order is being determined by our number of arbitrary constants. So since dalawa yung ating constant, it must be a second order differential equation. So how are we going to deal with this? So ang first is focus on our d operator na equation. So meron tayong d squared plus 5d plus 6y is equal to 0. So we have to factor out this second degree equation. So para magiging quadratic equation lang siya. So d2y is equal to 0. So reducing this into first order, so from second order gagawin natin siyang first. So as per our objective kanina. So by setting this as a single variable, say q. So let this q be equal to d plus 2y. So if so, this becomes d plus 3. Q is equal to 0. So converting this into general form, so magiging dq dx plus q times 3 is equal to 0. So this is actually a linear differential equation of dependent q. So again, kailangan natin kunin ang ating integrating factor, e raised to integral of the coefficient of our dependent variable. So that's 3 dx. So this gives you e to the 3x. And such integrating factor must be multiplied to our original differential equation. So ito yung ating differential equation na nabuo. So magiging e raised to 3x, e raised to 3x. So that this left side of the equation becomes the derivative of our dependent q and our integrating factor e to the 3x is equal to 0 because 0 multiplied by e to the 3x is 0. So integrating the 2 na, so pag in-integrate natin siya, This integral and derivative cancels out, gives you q e to the 3x is equal to integral of 0 is constant. So ang subscript natin ay mayroong constant 1 since we are expecting two arbitrary constants. So to solve for q, I need to multiply it by e to the negative 3x. So multiply lang natin siya by e to the negative 3x to cancel that e to the 3x out. So multiplying e to the negative 3x. So this becomes e to the 0. So that's why it becomes q. So c1 e to the negative 3x. But q is equal to b plus 2y. So substituting it there, ang ating equation now becomes b plus 2y is equal to c1 e to the minus 3x. So converting into general form, that gives you derivative of y with respect to x plus y times 2 equals c1 e to the minus 3x. So again, this is actually a linear differential equation of dependent y. So again, kukunin ulit natin ang ating integrating factor. So ang ating integrating factor will be e to the integral of the coefficient of our dependent is 2. So that gives you 2 dx. So which is actually e raised to 2x. But then again, I need to multiply my entire differential equation by our integrating factor, e to the 2x, so that this left side of the equation becomes the derivative of our dependent and our integrating factor, e to the 2x, equal to c1 e to the minus 3x times e to the 2x is c1 e to the minus x. Integrating the 2 with respect to x, of course. So this integral and derivative cancels out, giving us e to the 2x equals c1 e to the minus x. So ang ginawa natin dito, to integrate this e to the minus x, I need to provide here negative and then compensate a negative outside. Since constant yung c1, so I need to put that outside. Negative times constant 1 is still a constant 1 here. So I need to add na lang c2. So again, a negative number multiplied by a constant is still a constant. So it does not matter whether it is a negative or a positive, for as long as it is a constant. So to solve for the solution to that differential equation, I need to multiply this all by e to the minus 2x. So multiplying this by e to the minus 2x, this e to the 2x cancels out, gives us our final answer will be y is equal to c1 e to the minus 3x, because e to the minus 2x multiplied by e to the minus x is e to the minus 3x, plus c2 e to the minus 2x. So this will be our general solution to that differential equation. So c1 e to the minus 3x plus c2 e to the minus 2x. So the answer is D. So, pwedeng magkapalit yung C1 at C2, depende kasi di ba multiplication ito, so pwedeng mauna yung D plus 2 or ang sumunod dito ay D plus 3. So, since multiplication is commutative, so depende sa mauna mo, pwedeng magkapalit ang C1 at saka ang C2. So let's have example number 2. So we have here fourth derivative of y. It's not y to the fourth. So that's fourth order differential equation minus 7y triple prime plus 10y double prime is equal to 0. So ang ating sagot ay naka-express in terms of x. So ang ating independent variable ay x. So this is fourth derivative of y with respect to x. So which can be written as d to the fourth. Rewrite na lang natin. 7d cubed plus 10d squared. So second derivative yon. Y is equal to 0. So from there, this is our d operator, d to the fourth, that whose factors are d to the second, kasi ang common natin ay d to the second. D to the second minus 7d plus 10y is equal to 0. So factoring this out pa, so magiging minus 3. Sorry, it's minus 2 d minus 5y is equal to 0. So again, pwede natin siyang i-reduce into lower differential equation, lower order differential equation. So pwede natin itong i-let as q. So magiging itong d squared q is equal to 0. So, di ba pagka d squared q, pwede natin siyang i-rewrite as second derivative of q with respect to x is equal to 0. So, since to eliminate this second derivative, I just need to integrate this twice. So, magiging itong dq dx is equal to c1. So, because the integral of 0 is constant 1. So, integrating again, masosolve natin ang so again, i-rewrite ko muna. That's dq dx is equal to c1 dx. So integrating, magiging q na lang. That is c1 of x plus c2. But what is this q? So q is d minus 2, d minus 5. d minus 2, d minus 5y is equal to c1x plus c2. So reducing this again into of lower order, so magiging d minus 5y. So itago natin siya sa pangalang z. Then d minus 2z is equal to c1x plus c2. So converting into general form, plus z times negative 2 is equal to c1x plus c2. So solving for our integrating factor, so our IF there is e to the integral of negative 2 dx, so which is equal to e to the negative 2x. So multiplying this by our integrating factor e to the negative 2x gives derivative of our dependent z, and our integrating factor e to the minus 2x is equal to c1x plus c2 e to the minus 2x. So integrating this, gagamit tayo ng integration by parts. So let this be u. So using integration by parts, gagawin natin itong u, gagawin natin itong dv. So let u be equal to c1x plus c2, whose derivative u is c1, and dv is e to the minus 2x dx, whose v is equal to negative 1/2 e to the minus 2x. So integral and derivative cancels out. So what's left on the left side is z e to the minus 2x equals integral of u dv is u times v. So that's negative 1/2 quantity c1x plus c2 e to the minus 2x minus integral of v du. So this is minus 1/2, and that c1 becomes positive 1/2 c1 e to the minus 2x dx. I should have put that outside, pero later na lang. So this gives you z e to the minus 2x is equal to, when you distribute this one, so negative 1/2 times c1 is still c1 of x e to the minus 2x. And then this 1/2 multiplied by c2 e to the minus 2x is still c2 e to the minus 2x. So again, 1/2 times any constant will always be a constant. And then integral of the c1 e to the minus 2x, magpo-provide ng negative 2, magpo-provide ng negative 1/2. So this is negative 1/4. c1 is still a constant. So maglalagay ako dito ng another constant, c1 e to the minus 2x plus our constant of integration c3. So as you can see, you can combine these two into a single constant c3 or c2. Kasi c2 plus c1 is still a constant, so c2 na lang din ang ilalagay natin. So z e to the minus 2x plus c1x e to the minus 2x plus C2 e to the minus 2x plus C3. So let us try to erase this. No. Huwag na natin i-erase later na. So copy na lang muna natin. So mumultiply natin ito by e to 2x. E to 2x. So pag minultiply natin siya ng e to 2x, so this cancels out, matitira na lang natin dito ay z. So this is z equals. Burahin nga natin to. So palitan natin na equals. So magiging equals ito. So pag minultiply natin ng e to the 2x, makakancel out itong e to the minus 2x. So that gives you z equals C1x e to the 2x times e to the minus 2x. This cancels out. So magiging C1x na lang. Plus e to the 2x times C2 e to the minus 2x is C2 because e to the minus 2x and e to the 2x cancels out. So magiging plus C2 plus C3 e to the 2x is C3 e to the 2x. But then again, Z is equal to D minus 5y. So lalagay natin dito D minus 5y. So ZD minus 5y, so lalagay natin dito D minus 5y para ma-replace natin yung Z dito, equals C1x plus C2 plus C3 e to the 2x. So again, converting into our general form, so this is dy dx plus y multiplied by negative 5 equals C1x plus C2 plus C3 e to the 2x. So this is again a linear differential equation of dependent y na. So let w be equal to, we are to find the integrating factor na pala. So solving for the integrating factor, so this is e to the negative 5 integral of dx. So that's e to the minus 5x. So multiplying our equation by e to the minus 5x. So what will happen to our left side of the equation? So mangyayari, it becomes the derivative of our dependent y and our integrating factor e to the minus 5x, which is equal now to C1x e to the minus 5x plus C2 e to the minus 5x plus C3 e to the minus 3x. So this is e to the minus 3x. So distributing e to the minus 5x gives you this. So pwede nating i-integrate ito again by using integration by parts. Let that be u. So lagay natin dito, let u be equal to x whose derivative u is dx. dv is equal to e to the minus 5x dx. Then v is negative 1/5 e to the minus 5x. So integral and derivative cancels out kasi integrate natin ito lahat. So this cancels out. So y e to the minus 5x is now equal to C1 times the quantity, integral of u dv is u times v. So that's negative 1 over 5 x e to the minus 5x minus integral of v du. So that is plus 1/5 e to the negative 5x dx plus C2 integral of e to the minus 5x is negative 1/5 e to the minus 5x plus C3 integral of this one is negative 1/3 e to the minus 3x plus our constant of integration C4. So you have y e to the minus 5x is equal to C1 times that is C1. So C1x e to the minus 5x. Then integral of that is negative 1 over 5 times that is negative 1 over 25 e to the minus 5x times C1 is still C1 e to the minus 5x plus C2 e to the minus 5x, since negative 1/5 times C2 is still a constant, plus C3 e to the minus 3x, since negative 1/3 times C3 is still C3, plus C4. So, as you can see, lahat ng constant, binabaliwala na lang natin because any constant multiplied by constant of integration C1, C2, and C3 here are all constants pa rin. So, y now is equal to, so ang gagawin natin, imumultiply natin lahat by e to the 5x to cancel this out. So, multiplying that by e to the 5x gives y equals, gawin natin itim muna. Yep. So, this is C1 of x. This one, C1 of x. Cancel this out. Magka-cancel ito at magka-cancel. Matitira na lang ay C1 plus C2 is still a constant. That is, will retain as plus C2 plus, because C1 plus C2 is a constant, so iname pa rin natin siya as C2. Then C3 e to the minus 3x times e to the 5x is C3 e to the 2x. And then finally, C4 e to the 5x. So this therefore is the general solution. So C1x plus C2. So check ang ating C1x tsaka C2. So check lahat. So ang ating exponent ay parehas na positive 2x at saka 5x. So positive 2x, positive 5x. So that is letter C. So remember, sa pag-solve nito, lagi tayong titingin dun sa ating order. So para malaman natin kung ilan yung arbitrary constants, tapos ipa-factor out lang natin. And then another note na nakuha natin is that yung mga constant, kahit hindi na natin isama because constant multiplied by a constant will always be a constant.